Welcome everybody to Algebra 1, Section 3.5, Absolute Value Inequalities. So for an absolute value inequality, we have two such cases that we could have. One where we have the absolute value is greater than or equal to, or / greater than a number, and one where the absolute value is less than or equal to, or less than something. Now, for each scenario, we're once going to go back to the definition that absolute value is the distance from zero. And so as we mentioned in section 3.4 with absolute value equations, where this is saying that x is 5 or more from 0. It's 5 or a greater distance from 0. The distance from x is from 0 is greater than or equal to 5. And so there's two ways that can happen. One such way is for it to be at 5, a closed circle, and greater than that, or numbers that are bigger than that, such as 6 or 7 or 8 on that direction. So anywhere 5 and to the right would be greater than or equal to 5 away from 0. Now the other way for it to be 5 or more from 0 is to be at -5 and going to the left, because these ones go farther from 0. And remembering that 0 is in the middle, it's going away from 0 because it's getting farther and further away. And so we look at this and we're like, oh, that's kind of interesting because that looks like an OR graph. Well, and spoiler alert, it is an OR graph. And so we're going to have our interval notation reflect that, where for this part of the interval notation, we do -infinity, comma, -5, with -5 getting a bracket. And then the U for the union, then we do this part of the interval notation, which is 5, comma, infinity, with 5 getting a bracket this time. Now on case 2 here, we have absolute value of x is less than or equal to 8, which means that x is 8 or less from 0. So it's 8 or closer to 0. And so how we could do that is we could be at 8 or going to or toward 0, or it could be at -8 and going to or toward 0. And you notice, actually, wait, this looks quite familiar too to section 3.3. This looks like an AND compound inequality, and well, that's because it also is a compound inequality. This is just the AND one. So case 1 was the OR compound inequalities, while case 2 is our AND compound inequalities based upon this inequality symbol. And so our interval notation reflects this as well, where it's -8, comma 8, with both getting brackets because they're both closed circles / or equal to. And a way you can remember this, besides like I said, it has to be that or further from 0 for the greater than or equal to, or that or less than 0, closer to 0 for the less than or equal to. A little trick here, a corny trick, of course, is that you could do greater than rather than greater than, to remember that it's greater or, so it's an or common inequality. Whereas this one is less than. Less than is a good way to remember that. That is AND compound inequality when it's less than. And here on example 1, in case 1, this would have been like x is greater than or equal to 5, or x is less than or equal to -5. And so this would have been the less than or equal to -5, where this over here is the greater than or equal to 5. Whereas on the bottom one, it would have been like -8 is less than or equal to x, which is less than or equal to 8, because x is between -8 and 8, as we see there, as well as including 8 and -8. And so I want you to notice here that for case 1, when we had our OR common inequality, is that we had one inequality that was the exact same as this, the inside of the absolute value, x, and then we kept the inequality symbol in number. Whereas the other scenario was still the inside of the absolute value x, we made this right-hand side negative, which is similar to what we did in 3.4 with absolute value equations, but we also flipped this inequality symbol. That's a change that we'll notice today happens. Whereas for case 2, we had x in the middle, the inside of the absolute value. We had this symbol actually twice, before and after x, and we had this number after x and the negative version of that number before x. Now, what does this mean? Well, as we already noted, that it means that absolute value inequalities are compound inequalities. Absolute value inequalities are really compound inequalities, just looking like something else. which actually means, conveniently enough, we already know most of how to solve this one because we did it in section 3.3. Now, our steps here, we're going to have 4 steps, and we actually already did these steps back on case 1 and case 2. We're going to expand them or apply them to other different scenarios. So step 1 is to isolate our absolute value expression. So sometimes it's not isolated, okay? So we have to get it by itself, very similar to what we did in 3.4. Step 2 is to create 2 cases, and that's what I talked about here. So for case 1, for the greater than, we make one where we leave the inside of the absolute value the same for both, but for one of them we leave the inequality symbol and the number the same, equality symbol and the right side the same. The other one we flip the inequality symbol and make the opposite side negative. Whereas the less than, we do the inside of the absolute value in the middle, we do this symbol twice, before and after, and we do this number twice, before and after, but the before one is just negative. And it says use the KISS method. I don't like that explanation as much personally, but it means to keep it switch, which explains this case 1 a little bit with the OR, that you keep this and then you switch this and switch this is what it's talking about. Now step 3 is to solve both inequalities, or in this case solve both sides, all 3 parts of that inequality. And step 4 then is to graph it and put it in interval notation. So our directions there to solve, graph, write them in interval notation. So on number 1, the absolute value of x is less than 7, and so this is less than, and. So I put the inside of my absolute value, which is just x. I put this symbol before and after. I do this number before and after, but the before one is negative. And this is actually already solved. X is by itself in the middle, and so it's just negative 7 is less than x, which is less than 7. So congrats, we solved it. We did steps 1 through 3 already. Step 1 was isolate. There was nothing else around here, so it's already isolated. Step 2 is to make our cases, and that was this negative 7 is less than x, which is less than 7. We made that. Step 3 is to solve, where it was already solved. And now step 4 is just to graph. So I do a negative 7 open circle, positive 7 open circle, connect the two like an and inequality does, and now we do our interval notation, which is negative 7, comma 7, both with parentheses because they're both open circles. Neither of them are or equal to. On number 2 here, the absolute value of x is greater, so it's or, greater than or equal to 4. And so we have our one scenario we're going to make where it's the inside of the absolute value x, and everything else stays exactly the same. Then our or, in our other case, inside of the absolute value x, we flip our inequality and we make the opposite side negative. These are both already solved as well, so we don't have to worry about step 3, and so we call this our answer, and we go ahead and graph. So greater than or equal to 4 is a closed circle at 4 going to the right, where less than or equal to negative 4 is a closed circle going left. And like we saw earlier, this is an OR compound inequality, and so we make our interval notation reflect that with 2 separate parts with the union in the middle. So it's going to be negative infinity, comma negative 4, with negative 4 getting a bracket, and 4, comma infinity, with 4 getting a bracket. Next up on number 3 here, we're going to have the absolute value of x minus 1 is greater than 6. Our absolute value is still isolated because there's nothing around it. So recall that'd be like 4 plus this. We have to get rid of the 4, or 4 minus this, or this minus 3, or plus 3, or a negative 4 multiplying with x, so we have to divide it, or dividing by a 2, or anything like that would be not isolated. So it is isolated, and this is greater, and it's or, so it's x minus 1 is greater than 6, or x minus 1. The inside stays the same on both inequalities, x minus 1, but we flip our inequality symbol and make the other side negative. Now we solve each of these, and each of these we add 1 to get the variable alone, where we get x is greater than 7, or add 1, x is less than negative 5. And those are the compound inequalities. And so we have greater than 7, so it's an open circle at 7, going to the right, less than negative 5, an open circle going to the left. And our interval notation is negative infinity, comma negative 5 with an open circle, union, the U for union, 7, comma, infinity. On to number 4 here, the absolute value of x plus 2 is less than or equal to 7. So it's less than, so it's and compound inequality. So I'm going to do the inside of the absolute value, this symbol before and after, this number before and after, but making that far left-hand side negative. And now we start solving this. So to get our x by itself, I will subtract 2 to not just one part or 2 parts, but rather to all 3 parts, because whatever you do to one part, you do to all 3 parts here. And I end up getting negative 9 is less than or equal to x, which is less than or equal to 5. X is now by itself, so this is my compound inequality. And I go ahead and graph this with closed circles at negative 9 and 5. And now I connect the 2 like an and compound inequality should. And so it's negative 9, comma 5 with brackets on each. Moving on to example 5 here. The absolute value of 2x plus 5, is greater than 3. Notice I'm continuing to emphasize that greater versus less than. So in this case, it's greater than or equal to. And so it's the inside of the absolute value, 2x plus 5. And then the rest of it's just kind of the same as it has been. My 5 wasn't wanting to write there for some reason. Or 2x plus 5 is less than or equal to, we flip the inequality, negative 3. But the 2x plus 5 stayed the exact same on both inequalities. Solving, my first step is to subtract 5, and I get 2x is greater than or equal to negative 2. Then dividing by 2, I get x is greater than or equal to negative 1. Or, my other scenario, I subtract 5, and I get 2x is less than or equal to negative 8. Divide by 2, and I get x is less than or equal to negative 4. And that forms my compound inequality. So I go ahead and graph these, and greater than or equal to negative 1 is a closed circle here going to the right, while less than or equal to negative 4 is a closed circle here going left. And I do my interval notation for this or compound inequality, and that would be negative infinity, comma negative 4, with negative 4 being a bracket, u for union, negative 1 comma infinity with negative 1 being a bracket. Moving on to number 6 now, I have my absolute value no longer isolated. I have to move this minus 1 by adding 1 before I do anything else, before I start making my cases and all that good stuff. And now I have the absolute value of x plus 3 is less than 6. And so this is less than, so it's an and one, so I write the inside of my absolute value. I put this symbol before and after. I put the 6 before and after, but I make the left side negative. And now I go ahead and begin solving this by subtracting 3 to all 3 parts to get my variable by itself. And I get negative 9 is less than x, which is less than 3. My variable is by itself, so I've solved my compound inequality. Congrats to me. I go ahead and graph this with open circles at negative 9 and positive 3. And I connect the 2. And I get negative 9 comma 3, with both being parentheses, for my interval notation. On to number 7 here, in order to get my absolute value isolated before I can make my cases, I have to divide by 3 to undo the multiplication of 3. As I divide both sides by 3, I get the absolute value of 2x plus 8 is greater than or equal to 10. Some of us might want to try and distribute here. That's wrong. If you do it, you will not get the correct answer. You will get a correct answer if your math is right, but the other answer you'll get will be wrong. So do not distribute. Now we can make our 2 cases. Since this is greater, I do 2x plus 8 is greater than or equal to 10, or the inside stays the same, 2x plus 8, but my inequality flips, and I make the other side negative, so less than or equal to negative 10. So now I go ahead and subtract 8 from each, and I get 2x is greater than or equal to 2. Divide both sides by 2, and x is greater than or equal to 1. Or in my other scenario, I subtract 8. I get 2x is less than or equal to negative 18. I divide both sides by 2, and I get x is less than or equal to negative 9. And that forms my compound inequality. My box didn't want to form very well there, so we'll just manually. I'll do a closed circle at 1 and negative 9. and I'll connect the two. Oh, sorry, it's not, I'll connect the two, but they both go out because this is less than -9, and this is greater than -9, greater than, +1. But there was or equal to, so they were closed circles. And so now I do my interval notation. So on the left would be negative infinity, comma, -9, which once again we do go least to greatest. U for union, 1, comma, infinity, with 1 being a bracket. Starting off on number 8, we notice that, hey, this is a less than, but not for long, actually, because as I have to undo this -2 before we do anything else, I multiply by -2, or -2/1. On the left, these -2's reduce, and I get the absolute value of 4x minus 8. But on the right, I get positive 12, and now I have to flip my inequality because I multiplied both sides by a negative number. That rule still applies. So now this is actually greater, again, so I have 4x minus 8 is greater than or equal to 12, or 4x minus 8 is less than or equal to -12. Once again, I see some people doing this, using that instead of this part, and then making the other part here like that, and just continuing to solve this problem. This is when I see people make more mistakes, when they try to do things like this. A little shortcut there to write one less thing. And while it's not technically wrong, I do see it causing a lot of people to make mistakes. So I'd encourage you to go ahead and just write this part out like I did on mine. Now if I start solving these by adding 8, I end up getting 4x is greater than or equal to 20, dividing by 4, and I get x is greater than or equal to 5. Or, adding 8, 4x is less than or equal to -4, divide by 4, and x is less than or equal to -1, and that forms my compound inequality. I make closed circles for both 5 and -1, noting that since this is an or inequality, they go out or away from each other because that's greater than or equal to -1 and less than or equal to -5. Oops, I apologize, I messed that up. I did -5 and -1, where it's +5 and -1, and it's greater than or equal to 5 and less than or equal to -1. My apologies on that. My interval notation reflects this, though, that what I actually correctly did at the end there, not what I did originally. It'd be negative infinity, comma, -1, with a bracket with -1, U for union, and then 5, comma, infinity, with the bracket around 5. 2 more problems left here as we slide into number 9 here, and I have to first undo my subtraction, and then I will undo my multiplication. So I undo subtraction by adding 3, and I get 10 times the absolute value of x minus 4 is greater than 50. I then will say, okay, I can divide by 10, and I get the absolute value of x minus 4 is greater than 5. Since this is or, greater, I make my 2 compound inequalities in the following manner. The first one stays exactly the same, but drops the absolute value bars. The right one, I put or, and then I put the inside the exact same, x minus 4. I flip my inequality symbol, and I make the other side negative. Solving each by adding 4. On the left one, I get x is greater than 9. On the left one, I get x is less than -1. And the word or between them. And now I'm going to go ahead and graph this. So x is greater than 9 would be an open circle at 9. So it's all the way over here off the graph, a little past 8, and going to the right. And then less than -1 is an open circle at -1, going to the left. And my interval notation reflects that as it's negative infinity, comma, -1 for the one on the left, U for union, and then 9, comma, infinity for the one on the right. Once again, both parentheses like the first one was. On to our last problem of the section as well as of the unit. I have to undo this 1/2 as well as +11. The addition gets undone first by subtracting it. And I have 1/2 times the absolute value of 4x minus 4 is equal to, less than or equal to 4. Then to undo the 1/2, one might think I might divide by 1/2, but don't do this because it's quite messy when you divide by a fraction. You're like, oh crap, what now? Well, what you should have done instead is multiply by the reciprocal, which is 2 over 1, or just 2 because it's the same thing. 2 and 2 reduce, and so you end up getting the absolute value of 4x minus 4. We don't flip our inequality here because we multiplied by a positive, and is less than or equal to 8. Now I have to make my new inequalities here, so I leave the inside the same, and because it's less than and, I rewrite my inequality beforehand and afterwards, the same exact. I write my number before and afterwards, but I make the left one negative. Now I'm going to add forward to all three parts. And I get negative 4 is less than or equal to 4x is less than or equal to 12. Then we're going to go ahead and divide everything by 4. And I get negative 1 is less than or equal to x, which is less than or equal to 3 as my answer. So I do close circles at negative 1 and 3, and then I go toward each other here. So negative 1, 3, and they go in the middle like an and inequality should, or very similar to an eighth note for music. And so I do a negative 1 comma 3 with brackets on each. So in summary, we need to make sure that we note whether it's great or versus less than, and make our compound inequality accordingly. Then it's just like solving compound inequalities from section 3.3. And that wraps up section 3.5 of Algebra 1.